Hadoop performance tuning, presented by Varun. Introduction. Hadoop is an open source framework for distributed storage and processing a large data sets using a cluster of commodity hardware. While Hadoop provides a scalable and fault tolerant platform for big data processing, optimizing its performance is crucial to ensure efficient processing and resource utilization. Hadoop performance tuning involves configuring various parameters and setting to achieve better throughput, reduce job execution times, and improved overall efficiency. Hadoop performance tuning strategies and techniques for optimizing the performing of Hadoop cluster. Cluster configuration. Ensuring that your cluster hardware is well figured. This includes optimizing the number and specification of nodes, balancing resources, CPU, RAM, and disk across the cluster, and choosing appropriate network settings. Hadoop configuration. Adjust Hadoop configuration parameters based on the characteristic of your data and workload. Key configuration files include core site.xml, HDFS site.xml, and mapred site.xml. Tune parameters such as block size, replication factor, and heap size for the name node and the data node to suit your data and cluster size. HDFS configuration. Optimize the Hadoop distributed file system for better performance. Adjust the block size based on the size of your data and nature of your workload. Smaller blocks may be more suitable for large number of small files. Hadoop performance tune. YARN configuration. Yet another resource negotiator is the resource management layer in the Hadoop. Configure YARN parameters in the yarn site.xml file. Adjust the memory location for container size, queues, configuration, and other settings to optimize resource utilization. Job configuration. Optimize job configuration based on the specific requirements of map reduce jobs. These include settings, the number of mappers and reducers. Choosing the compression codecs and configuration speculative execution. Data serialization. Choose efficient data serialization formats to reduce the amount of data transferred between nodes and stored in the HDFS. This can significantly improve job performance. Speculative execution. Enable speculative execution by for map reduced jobs to mitigate the impact of slow running tasks. This can helpful for improve overall job completion time. Data compression and serialization. Use data compression algorithm to reduce the amount of data transfer over the network and stored in the HDFS. Choose serialization formats like Avro or Parquet to improve data read and write performance. Network optimization. Ensure that the cluster nodes have high speed and low latency interconnects. To facilitate the efficient data transfer between nodes, minimize the impact of network latency by collocating data and computing whenever possible. Regular updates and maintenance. Stay informed about the Hadoop releases and updates. Regular update the Hadoop distribution to benefit the performance improvements and the bugs fixes. Common performance bottlenecks. Hardware limitation. CPU bottleneck. Inadequate processing power can lead to slow job execution times. Ensure that the node is cluster have sufficient CPU resources. Memory bottleneck. Insufficient RAM can result in frequent disk input output, reduce overall performance. Adjust JVM sizes and monitor memory usage. Disk bottleneck. Slow disk speed or high disk contention can impact read and write operation. Use fast disk and distribute evenly across nodes. Network bottlenecks, high latency, network congestion, HDFS bottleneck, small box size, replication overhead. Yarn bottleneck. Resource contention. Inadequate allocation of resource by yarn can lead to resource contention among the application. Adjust yarn configuration, including container sizes and queue settings. Node manager overhead. Overloading the node managers with too many containers can impact the performance. Monitor and adjust node manager configuration. Map reduce bottlenecks. Inefficient job design. Poorly designed map reduce jobs with inefficient mappers and reducers can lead to longer job completion time. Optimize the design of the map reduce jobs. Conclusion. In the conclusion, Hadoop performance tuning in the critical aspects of the ensuring optimal and efficient operation of Hadoop cluster. The process involves addressing various factors including hardware configuration, Hadoop and HDFS settings, job design, and the network consideration. By following the guidelines, organization can ensure that the Hadoop cluster operate efficiently, deliver optimal performance, and effectively handle the challenges posed by large-scale data processing workloads. Continuous monitoring, adaptation to changes, and knowledge sharing are the key to maintain the performance gains achieved through the tuning process. Thank you.